Our first speaker for tonight is Lesedi. Can you guys still hear me? Okay, cool. So Lesedi is also a software engineer here at BBD. He's one of those people who you would see at the top when you look at lead code. Who uses lead code? Yeah, that's Lesedi. And Lesedi will be talking to us about learning Git the fun way, or learning programming the fun way by actually building Git. Welcome, Lesedi.
Hello? Can you guys hear me? Okay, cool. Okay, testing. Okay, cool. There was some feedback there. Good evening, guys. I hope everyone is doing well. And yeah, so I already got introduced. My name is Lesedi. I work here, and I'm gonna be. Oh.
It's a slight delay.
Yeah. Cool. All right. So, learning programming the fun way by building Git. I think those who know me will know that I am a very big fanatic when it comes to lead coding, and I've completed over like 500 questions. And the thing with lead code is that when you're solving it, you focus on specific concepts. So these concepts are essentially isolated, and you solve them in isolation. And one day I thought to myself, what if I put everything together and build something with all of these concepts? And while I was watching a YouTube video, Git came up. You know how YouTubers make it look easy, like, yeah, I just press. Essentially, that's what happened. So in order to build Git, we need to understand what Git is. So if you read the docs, Git describes itself as a content addressable file system. What the hell is that? Essentially, it's key value pairs, right? So this is what a key value pair looks like. But wait, I thought Git was essentially a graph. So this is what a graph would look like. But essentially, these key value pairs, they point to one another, right? And you find a key value pair within a key value pair, within a key value pair, until you eventually get a graph. So essentially, that's what a graph is. These key value pairs essentially take form, they are essentially objects, right? And in Git, we have 4 different objects, but I'm just gonna focus on 3, to simplify things. So essentially, we have a blob, a tree, and a commit. So the blob is the actual file that you work on. So that's your .js, .java, .py, .whatever you're into file. So that's the physical file. And then you have your tree object. So essentially, a tree object is a list of all the blob objects. So think about it like this. It's essentially all the changes or all the files that you wanna commit or save within this tree object. And then finally, we have our commit object. So you'll notice that in our commit object, we essentially have a message, okay, from the top, a tree, a parent, author, committer, and the commit message. So essentially, this holds information about who made these changes, what changes were made, and what is the previous object that was that was the latest before. Yeah. This is what the objects look like if they have values. So essentially, each object, as you can see, they have a header, and the rest is the content. So the header contains the type of object and the size, right? As we saw in the previous slide. And then below that is the actual contents of the object. So all the objects follow a similar pattern. Cool. So when you put everything together, essentially this is what you have, right? You have a commit which points to a tree, which points to a file that you just committed, right? Our second commit will point to the first commit, which has a tree, which now has a test.py, which is a new file that we just recently committed, and pointing to the previous file, because we keep track of that as well, right? Yeah. And in our last commit, we have a tree, a commit object again, which points to a tree, which points to the new changes that we made on our py.main, and essentially the old test.py, because we keep track of everything, right? So that's how Git works. If you pay attention to these squares or these objects, you'll notice that we essentially have at the top left corner, we have a string of random numbers and letters. So what does this represent? It's a hash, right? Those represent a hash. So what is a hash? So a hash is a string of random letters and numbers. That describes the object. So essentially, if we have key value pairs, our hash is the key and our object is the value. So in other words, that is how we are able to grab an object or to reference an object, right? Yeah, go ahead.
Is the hash value not formula made up of the contents of that object?
Yes, it is.
Because otherwise the hash value has no reference
to the, yes. So for those who didn't get the question essentially was, is the hash value made up of the contents of the file, formula of the contents of, content of that object. And the answer is yes, it is. Essentially, it behaves as a checksum. Yeah. So objects are identified by a hash, and normally the hash is, I wrote 20, but it's 40 characters long. Sorry for that. This is an example of what a hash looks like. So this is the 444 hash. Obviously, I couldn't put it in my diagram for obvious reasons. It doesn't fit. And all objects live in the git/objects directory within the hidden git folder, right? And you'll notice that within the objects folder, the first two characters essentially make up the directory, and the rest of the hash is the actual object. I didn't do proper research on why. For now, it's just the way it is, right? Yeah, sorry about that. Cool. So there are two main things that we need to build, right? Or that we need to consider when we're working with objects. It's reading and writing objects. Easy as that, right? Yeah. So we're gonna do, I'm gonna show some code snippets. So we're starting off by reading a file. So this is our method header, which receives a hash, right, for the particular object that we want to see or read. We create a path object, right, and we point to get objects, and then we create the directory of the object itself. Then from here, we have a file input stream, right, which takes the path object and reads from that. And then we have an inflator input stream, which essentially decompresses the bytes, right? And we take those bytes and we write them to our byte array output stream. Yeah. And we take those bytes, convert them into a string, and then you can see there at the bottom I was printing them out, and then now I'm not anymore. So we return the content, and that's how we read an object. Easy, nah? Yeah. So now we are going to look at creating an object, right? So I call this hash object. So in this hash object method header, we receive the contents as a byte array, right? And then the type of object that we want to create, a Boolean, which, if I'm being honest, I should have left out. But essentially, sometimes when I was debugging, I would not create the objects because I felt as though I was just creating a bunch of stuff and never deleting it. Cool. So we then create our header and content, and then we write those to our byte array output stream, right? And we convert that byte array output stream into a byte array. And then, as the gentleman asked, we take all of those bytes and we generate a hash from it using a message digest. And I'm using an algorithm, the SHA-1 algorithm, which in hindsight, I should have been using, I think, 20 something. Yeah. Because this has been proven to produce hashes which are the same, and that is like bad for business. Yeah. And then if we want to, then we create a path object, right? And essentially we Then we create the file using the path object. And then before we write to our file, we use the deflator output stream, which compresses the contents, and then that gets written to our file output stream. And yeah, that's essentially how you create an object. So what's next after all of this, after being able to write and read from a file? It's building the actual commands, right? So in Git, we have two types of commands. We have plumbing commands and we have porcelain commands, right? So what is what here? The plumbing commands essentially are the low-level commands which interact with the file system or with Git directly, right? And the porcelain commands is the commands that make use of the plumbing commands, and you don't have to interact directly with Git itself. So essentially, those are the user-friendly commands that we use every day. And this is what they look like. Anyone who has used Git, I'm sure you are familiar with this, right? And I'm not sure.
Where's the merge? Someone else is merging.
Unfortunately, yeah. And plumbing commands is what you see on the left. Have you ever seen any of this by show of hands? No? Yeah? Yeah. So you'll notice that you hardly ever interact with the plumbing commands directly, but you do interact with this all the time. In fact, so much so that we have IDEs that do it for you, right? You don't have to do it yourself. Yeah. Cool. So now we're gonna dig into some code a bit, and yeah. I hope you guys can see my screen. Can people
Can you
see?
make it a little bit bigger?
Oh.
And we appreciate you selling VS Code at the same time.
No problem.
And we see that you've got a Copilot license. We'll be watching you.
I do have. NetBank is paying for it, but I can only use it on my NetBank laptop. Cool. So I don't know if you guys can see the files. So I'll just try to make it bigger. So here what we have essentially is all the commands that I've attempted to build. Yeah, I'm not gonna lie, it was quite tough. In the beginning, it was quite tough. But as time went on, you kind of like catch on, right? And you start to see how things work. And you eventually build, yeah, you just eventually get into the flow. Cool. So now it's time to show off a bit of what I have done. Can you guys still hear me? Cool. So in the root of the project, I created this hello world.txt. So this is me essentially like showcasing how we hash an object, how we create an object, and how we read from that object, right? So here goes nothing. So we have our hash just above the build success, but I could be making this up, you know, like I honestly could be making this up. So I am going to hide this and then run this command to show that we actually have the object. The object is actually there. So as you can see, there's our hash. And if you have a look here, C3, so essentially the first two characters, as we discussed prior, are used as part of the directory to the object itself, right? And then now we read from the object. So we are going to cat file. Yeah, it says it's not there. Oh, I know why it's not there. Because we need to use the object itself. So within the hello text file, this is the contents that we have. Do you guys agree? No? No? Disagree? I can also do an example with another file. Yeah, but we'll get to there. Cool. So I'm going to create a branch, right? And essentially, if I create a branch, then the IDE should be able to pick it up. My VS Code should be able to pick it up, right? No? Yes, no? No,
VS Code never does anything wrong.
Cool. So I am going to check out -b, Lesedi is the best. That's the branch name I'm gonna create. And if you look down there at the bottom left, that should update into the branch that I'm gonna create, right? Yeah? There we go. Let's make a commit. Let's commit something.
And then show me a triangle merge, okay? Because if you can't triangle merge, then...
It's future. Cool. So commit command, can people see that? I just committed. So how do we see that I actually committed? Git log, right? So essentially if I run git log, then we should be able to see it. No? Yes? Cool. This is a message. I just created it. This is my name. And I couldn't quite get the date right, as you can see. It's in June 1st and then 1970. Yeah, I struggled a bit with that, and I told myself I was gonna do it. And if you pay attention, you will see that we actually created this commit in this branch. You see that? Yeah. Cool. Oh, and there was actually one more command that I wanted to show. It doesn't do much, but I thought it was cool. So essentially what rev pass does is looks at the head, which contains the current branch that we're in, which contains the latest commit, and returns that hash. When building this command, one of the things that they said, or one of the things that I read, is it's called the Army Swiss knife of Git plumbing commands. Essentially, if you need to find the latest commit in any of the revs, which is any of the branches, use this. If you are looking to see what current branch you're looking at and the latest commit on that branch, you look at the head. Pretty cool. So what is the point of all this, right? The point was to learn and understand, right? Trying to understand the tools that we use and simply what it takes to build any of these tools, right? I should say that I used a lot of AI trying to understand some of the concepts, because how do you convert signed bits using bit masking into unsigned bits? That's a mouthful. It's a mouthful. I learned that Java, as part of Java's architecture, they sign bits for you. And I didn't fully understand this. And when I was writing and reading from files and objects, things were just not adding up, because Java essentially signs stuff for you, and the stuff that is within Git, the object itself, are written with tools where you can choose between signed and unsigned, right? So that means you have to do the conversion yourself. So unsign the things, then you can read them, and then when you put them back in, then unsign them again, essentially. I actually learned how to implement a graph using files that point to one another, that do all of these things. What I would normally do is like work with a graph with nodes that are in memory, and that's really easy compared to this, right? It's taking all of those concepts that I learned in lead code, right? Solving all those 500 questions and coming back and putting it together to form Git, or this Git. So yeah, thanks guys for listening. Questions?